Hey everyone, this is my seventh and final update on my Commodore 64 VIC-II replacement slash enhancement project. So it's been a while since my last video. The project stalled when I discovered that the Spartan 6 FPGAs had increased in price so much that it would make the board crazy expensive. When I started the project 2 years ago, before COVID, I chose the Spartan 6 FPGA family. It was an older FPGA, but it was still in production, and the price was reasonable. When I made my prototypes, the PCB Way charged me only $10 for a Spartan X9, and the X16 could be had for around $16. After I finished my design around the Spartan 6 in January, I found prices had gone way up. Suppliers were asking anywhere between $100 and $200 per FPGA, which was just ridiculous. I think there was some price gouging going on there, since there are probably so many designs that use those FPGAs. They were in short supply and high demand. Xilinx said that they would not be able to fulfill existing orders, and delivery might be delayed by as much as 2 to 3 years, and that killed any hope of making a reasonably priced board. Any Spartan 6 based designs are effectively dead unless at some point in the future there ends up being a glut of those chips. So it was clear that I had to abandon that FPGA and switch to another one. I could have gone with the next generation Xilinx, but those are fairly pricey FPGAs and even more overpowered for this project, and are still hard to find. So when I went hunting, and I discovered DigiKey had a good supply of a lesser known FPGA, this Phoenix Trion FPGA. They're a relatively new FPGA manufacturer, and DigiKey seemed to have lots of these. And by looking at the specs, it looked like this would do the job, and they were also relatively inexpensive. And that's probably because there weren't a lot of designs that used them, so I ordered a dev board, went through all the steps to port the project over to this new FPGA, which took way more time than I thought it would. And by the time I got the core working on the dev board, those FPGAs became unavailable or had a really long lead time. So practically overnight, all the stock just vanished. So it looked like I just picked the worst time ever to try and make an FPGA-based retro project. I wasn't able to validate the PCB design for the new large board with HDMI and RGB, and I didn't want to take pre-orders for a design that relied on parts that I couldn't get, so I ended up splitting the design into 3 different models, which I sort of had intended to do all along anyway. The first is the large model. That has all the bells and whistles, including HDMI and analog RGB output. The second board is, I'm calling the Mini, and it's basically the same as the first board, except HDMI and analog RGB have been removed, and it's also much cheaper to manufacture. Just the specs on the board, it's smaller, and the package makes it less expensive. And the third option is basically the same board as the Mini, can be populated differently with a cheaper FPGA, like one of the smallest ones, and you remove oscillators and the EEPROM, and it gets fixed to either NTC or PAL, and that's just what I'm calling a POV, or plain old VIC. And I'm pretty sure the BOM cost can be around $30 for that design. I did manage to put in an order for a batch of the Mini boards, which have arrived and have been programmed and tested, and they're ready to go. I also have 7 of the Spartan 6 based larger boards from my supply of Spartan 6, my dwindling supply. So I have 44 of the Minis, which again is everything except HDMI and analog RGB. It's less expensive than the large board, which is getting more expensive day by day because prices are increasing. As I said, I have 7 of the large ones. The large ones are probably best for new 64 builds using like a 60 clone PCB, or for example, or boards that have the RF shield around the clock circuit removed. And you can wire either HDMI or RGB out the back more easily on those boards, because you end up removing the RF modulator. And there are holes exposed at the back, so just keep that in mind if you're interested in getting one of those large boards. So now that the core is done, I will be open sourcing that very soon, as soon as I get these boards out there. So just watch for that to show up at the VIC-II Kawari GitHub repo. As far as hardware goes, I'd like to continue to recoup some dev costs, but eventually I imagine I will just open hardware these board designs, especially the Mini and POV for sure. But I think I need a little bit more time to get a new version of the large board up and working, and that will unfortunately be pretty expensive unless prices come down in the near future. So yeah, take a look at the Spartan 6 listing. Those may be the only Spartan 6s I ever make, because it just looks like they're just not going to be produced anymore, or just very difficult to find. So I've made those available on eBay for sale right now. I apologize for the free-for-all, but I'm more comfortable manufacturing what I can and selling them rather than taking pre-orders and possibly not being able to deliver for a long time. The 44 boards that I have took like 5 months to get. At one point, the fab house was shut down due to COVID outbreak. It's just been very frustrating to say the least, but at least this board is now proven to work and I can repeat the order. I sent out an announcement on the email distribution list that I have these 2 eBay listings out. Listings are for both, the listings for both are in the description for the video. I know that since the boards originate in Canada, it's not ideal for EU, UK users since it adds significant costs for shipping and import duties. If you're in North America, it makes more sense. Still working on a solution to get these built for the EU, but if you're interested in helping out the project and don't mind the extra costs, I'll still ship to the EU, UK. If you're interested in the larger board, you'll have to wait a bit longer as I build the prototype and work with the PCB fab house to build them. Unfortunately, things are getting even more expensive as time goes on. Parts are going up in price and it's making the large board even less affordable. So that's the status of things. Supply chain issues really threw a wrench in the whole project, and I'm doing the best I can to get these out there. Now that the Mini and POV models are a proven design, I can just repeat the order. Hopefully I can get more out there if there is enough interest. So latest updates. Someone asked me recently if they put a Kawari in with all the enhanced features in their 64, do they really have a 64 anymore? And to that I say you get a 64 compatible something else. I don't know exactly what to call it. It's not an entirely new machine, but more like an upgrade with some features anyone can use and some that are directed towards 8-bit programmers to play with. My intention was not only to provide a replacement, but also something new to tinker with. And that tinkering is targeted to towards a development crowd, and that's also why I made the core flexible and started working on a replacement-only version, which strips away all the extra bells and whistles and just acts as a replacement. That's the POV model. The small board, as I said before, can be configured with a smaller capacity FPGA, the oscillators removed, and the EEPROM removed, which saves something like $10 off the BOM cost. However, I wanted to get this fancier version out with the extensions to maybe build a small community of tinkerers to enhance existing software or make something new. So here's a quick summary of those features. So the things that anyone can use are the fact that it's compatible with 6567 or 6569. You can switch it. The palette is configurable, so you can save preferences that way. It can bypass a non-functioning clock circuit. You can hardware switch it. There's an 80-column text mode, basic wedge that you can play around with. There's also a white line killer that I'll explain later. And with the large board, there's the digital or analog video output options. And then on the other side, for the 8-bit enthusiasts, I added a bunch of extensions that you can play around with. So programmatic palette changes, for example, you can make it part of your program. There are new high-res modes. For example, 320 by 200. I added 160 by 200 16 color mode, and an additional 64K of RAM. I added DMA between DRAM and VRAM, or vice versa. There's block copy fill. There's also some math divide and multiply routines that you can take advantage of. And I added a graphics splitter that I will describe a little later. And you could even make your own variant and change the behavior of the VIC in whatever way you want. So if you're into the programming side and want to play around with something new, if not, you just want a VIC replacement, you might be better off just waiting for just the POV board, which will be less expensive, as I mentioned. So compatibility, so the Saruman was reported by Jan Beta to not be completely functional. There was some intermittent issues. However, I tested myself on my 64 and it seemed to work fine. I couldn't find any problems, so I either fixed the problem or it might be related to the board, something different on our motherboards. So, but that testing was successful for me. So I've tested with the final cartridge 3. I didn't find any compatibility issues. Super CPU will work provided the motherboard oscillator is used. And I have tested the Kung Fu Flash cartridge and it is working well on my system, although some people have reported that it was flaky on their system, and I'm not sure if that's something that I had already fixed or if it's just the version. So I'm using, I think, version 1.41 of the firmware, and it seems to be behaving very well for me. And the MK2 board does not identify the chip properly, and there are intermittent issues, and I don't have one to try and find out exactly why that is, but it can probably be made to work in the future. It just depends on what the MK2 board is doing to try and identify the chip. So the second update is I added a white line killer. So if you've ever connected your 64 to an HDMI monitor through an upscaler, like the RetroTink, you may have noticed that there's a white line on the left side of the screen, and it's not clear why the VIC-II does that, but it's also seen on, I think, some NES systems too, so maybe it has a purpose. The first release of Kawari did not have this white line, but I was advised to possibly include it just in case some hardware was expecting it. But you can turn it off now, and there's an option in the config utility to turn that off. So if that's something that annoys you, then there's this solution. That white line will just go away. So as I mentioned, I added a DMA transfer, and what that does is it lets you copy memory quickly from DRAM to VRAM or vice versa without the CPU doing any work. So if a DMA transfer is initiated, the Kawari will transfer bytes using idle graphics fetch cycles. And there are these are cycles that are normally, they do nothing and read from location 3 FFF, and they happen outside the visible region. So I just took advantage of those idle cycles and did some work that the CPU doesn't have to work to move memory between video RAM and DRAM. So I'm not sure if I mentioned in my previous videos, but I also added a divide and multiply routines registers in Kawari, so you can replace expensive loops that do divide and multiply with just a few instructions, and the results are just almost instantly available on the next cycle. So that's something that's interesting to play around with if you have the source for a program, and I'll show an example of this. If you have the source and you find that there's a divide or multiply routine, you can easily replace that with just a few instructions and then take advantage of the speed that the Kawari can offer. And then finally, while I was waiting for the small boards to be produced, I worked on adding a graphics blitter to the high-res modes. And what this does is it lets you move graphics data from one region in video memory to another quickly without using the CPU. It can also apply bit operations on the results or do things like make one color in the source bitmap transparent. The end result is you get kind of sprite-like behavior with some coding techniques. There's an upper limit to how much data you can transfer per frame, since there are only so many cycles within the non-visible region, but there ought to be enough to do some interesting things in the low-res modes. So this is a summary of the new modes that are available: 160 by 200, 16 colors, 320 by 200, 16 colors, 640 by 200, 4 colors, and 640 by 200, 16 colors, but each 8 by 8 cell has a foreground color. And then finally 640 by 200, and which is the 80 column text mode. And then it just shows here how much memory each takes up. So I put together a demo, and it's not a super fancy, flashy demo, but it's meant to just demonstrate what kind of extensions are available and what you can do with them. So there is some background music in here, but I'm just going to kind of turn it down, and I'll talk about what it is you're watching. I'll also just cut out the loading time, so I might just make some cuts here, just so we don't have to wait for the long loading times. So this first part just demonstrates that the color palette, the 16 color palette, can be configurable. So you can make that part of your programs. You can change the palette. Here it's showing red, green, blue, but you also have to change hue saturation value in separate registers for the composite output. So there are two different color models, and I do have a routine to make that a little easier to convert red, green, blue into hue saturation value. It's not a perfect match, but it's just it's good enough. And this is the 80 column mode that I demonstrated before. It's just showing some of the block move routines that make the scrolling fast. And just keep in mind that if you have the mini model, this does not look good on a TV. It might look good over S-Video and possibly through an upscaler, but the bandwidth is just too low on your average TV to show anything close to a crisp image for the 80 column mode, so just keep that in mind. And here's an example of 320 by 200 with 16 colors, just showing you that because you can change the color palette, you can get a better image out of the display. And this next mode is a 640 by 200 with 4 colors. There are also other modes that you can play around with. There's 160 by 200 with 16 colors, and another 640 by 200 with 16 color mode, which has colors per cell. So this next sequence demonstrates the DMA transfer. So what I did is I found a program that will convert an MPEG into an animation for the 64, and each frame is like 1K, and there's a code page. So what you're looking at are custom characters for each of the 256 characters that are available, and there's a code page that finds the best match, I guess, for each 8x8 cell. And so what this is doing is all the data is in the new 64K of video RAM, and it's using DMA transfer to basically move that each frame into the screen memory into regular DRAM. And it's doing this at 30 frames a second with basically very little CPU. You basically set up the the locations and just tell the Kawari to go, and it just does all the copying, and then your CPU is freed up to do other things. And so this is another example. I think I mentioned this before. I found a program that rendered the Mandelbrot set in low resolution, and I found a multiplication routine that does the normal loop. So this is an example of using the 6510 to do the multiplication per cell, and you can see it's quite slow. And what I was able to do was replace that routine that did the multiplication using the 6510, using loops, with just a few instructions for the Kawari to do the multiplication instead, and you can see it's much faster. So that's the kind of an example of what you can do if you have the source for an existing program. You can use the Kawari to kind of enhance it a bit and take advantage of some hardware-backed routines. And then finally, this is the high-res graphics splitter I added. So what that does is it copies rectangular regions within video RAM, and it does it without the CPU. You just basically set up the coordinates, and you say you poke some registers, and it will just do the transfer. The splitter supports source pixel copy and or XOR, and you can also have transparency. And so this is an example. Everything you see on the screen here that moves is not a sprite. It's just drawn each frame using the splitter. So yeah, fun stuff. So that's it for now. I think this will be my last video update. Hopefully the eBay listings will go well, and I will keep in touch through the email distribution list and inform people of availability of these boards if they're interested. Again, sorry for the free-for-all, but just things, manufacturing these things are just proving to be difficult in these trying times. So hopefully the supply chain issues will clear up and things will get better. Alright, thanks for watching.